So our next page here, I'm going to jump around. I'm actually going to do these two questions first, these second and third examples first, and then I'll go up to the prove it questions. But that way we get to see the formula a little bit more. So if sine of A is root 5 over 5, find the cosine of 2A. Okay, we don't know a lot of information about this. So we're just going to say, okay, sine of A is root 5 over 5, find the cosine of 2A. Now, the nice thing about all these cosine formulas, we have three. We have cosine squared of A minus sine squared of A. We have 2 cosine squared of A minus 1. We have 1 minus 2 sine squared of A. That if we're only given one piece of information, I can just use one of the formulas. I don't have to go out and find anything else. So I'm just going to use this last formula here because I have sine of A. I don't need to find cosine squared of A, and I don't have a lot of information to do that. And that's just going to be a lot of work, and I don't want to do it. So I'm just going to use my formula 1 minus 2 sine squared of A. So 1 minus 2 sine squared of A. This is going to look like 1 minus 2 root 5 over 5 squared. We are plugging this thing in for sine of A. We are plugging in root 5 over 5 for sine of A. So 1 minus 2 root 5 over 5 squared. We distribute the squared, so this looks like 5 over 25. So I have 1 minus 10/25. So, and if I find common denominators, this would be 25/25 minus 10/25, which would be 15/25, which would be, if I divide everything by 5, which would be 3/5. So that would be cosine of 2A. And that looks great. That looks perfect. All right, and then so similarly for the next example here, so if cosine of A is equal to negative 3/4, find cosine of 2A. So you only have the cosine, so I'm going to use my second cosine formula in order to find this problem out. I don't need to find sine, so don't do it. It's just going to be more work. You don't have to do more work. So the formula looks like 2 cosine squared of A minus 1, 2 times negative 3/4 squared minus 1. We plug in this negative 3/4 for the cosine of A. So 2, negative 3/4 squared is going to be 9/16 minus 1. Okay, 2 times 9 is 18, so 18/16 minus 1. Finding common denominators, 18/16 minus 16/16 would be 2/16, which would be 1/8. All right, looks great. So that's how we do it. That's how we find it. That's just plugging into the formulas. So not too bad. So let's go up and let's see this prove it question. So prove 2 sine 2x is equal to 4 over tangent of x plus cotangent of x. All right, so prove it question 5.1 looks kind of intimidating. Based off of kind of what I can tell here, you can either work either side. I'm just kind of taking a look at it and saying, what should I do? You could either work either side, either the left or the right. I actually think we would get where we need to go quicker if we work the right side. I do think the right side's the quote-unquote uglier side of the two. The best that we can do on this left side is just to rewrite sine 2x, and that's not going to be very helpful in a quick amount of time. We're going to be like, oh, what do we do now? So let's rewrite this right-hand side. Okay, so 4. And then let's write tangent of x, cotangent of x as sines and cosines. So 4 over sine of x, cosine of x plus cosine of x, sine of x. All right, so ignore the 4 for a hot second. Let's get common denominators and let's add these two fractions up. So on my left side, I'm going to give myself a sine of x on the top and the bottom. And on my right side, I'm going to give myself a cosine of x on the top and the bottom. Give the other one what it's missing. So this is going to look like sine squared of x over, oops, put a 4 in there, 4. sine squared of x over sine of x cosine of x plus cosine squared of x over sine of x cosine of x. All right, a little cramped up in here. All right, we're going to combine, we're going to add these two fractions. We have a sine squared plus cosine squared, so that's pretty exciting. So I'm going to just change that to a 1. So this is going to look like 4 over 1 sine x cosine x. All right, so I'm going to continue this on the other side. All right, so like I said, I want it to look like 2 sine 2x, and we're getting close. Okay, sine of 2x, as to remember, looks like 2 sine of x cosine of x. That's what it looks like. We're very close. We are very, very close. So when we add fractions, we keep the top, or we keep the first. We change the big division to multiplication, and we flip the second. So I'm going to divide these two fractions. Keep the first, change the big division to multiplication, and flip the second. All right, so I have 4 times sine of x cosine of x over 1, or just 4 sine of x cosine of x. Okay, now sine of 2x is 2 sine of x cosine of x. So we're going to get a little fancy here, and I'm going to break apart this 4. I'm going to say 2 times 2 sine of x cosine of x. Totally legal. You can completely do that as long as the math works. And then I have 2 times sine 2x, which is what I started with. So looks great. I think that if you were to work the left-hand side, you kind of get stuck pretty quickly. So I would not do that. I would really work the right side. And it's not so bad. You're just getting common denominators in your fractions, and then you're going to divide, and you should get what you need to get. Maybe the trickier part, maybe the not so obvious part was to split this 4 up into 2 2's. Okay, great.